Hello guys, in this video we are going to discuss about top 10 questions that could be asked from haloalkanes and haloarenes for NEET. Before the start of the video, I would like to recommend that before I start doing the solution, you should solve the question on your own by pausing the video, and after solving the question and getting an answer, then see the solution. If there is a mistake, you would remember that, and if you are right, then you would have saw the solution 2 times, which would help you remember more. So now let's start. Here is the first question. It is an propene with HCl peroxide. So the usual reaction of a student would be that it is a Halous acid with peroxide, so peroxide effect or Kharash effect would occur. But no, in this case it wouldn't occur. The peroxide effect only works with HBr, neither with Hi nor with HCl. The reason for that is when the Kharash effect occurs, the O single bond O of the peroxide breaks, producing OH radical, which attracts the hydrogen radical from the HBr, leading to the production of the bromine radical, which attacks on the double bond and cause the formation of an allylic intermediate. But here HCl is, so no peroxide effect would occur. It would be the normal electrophilic addition leading to the formation of 2-chloropropane. Next question. Here it is 2,3-chlorobutane with zinc triether. Now this reaction is called Franklin reaction. It is an anti-elimination reaction. So it would remove the 2 chlorine molecules, leaving a double bond, which leads to the formation of butene. Next question. Aniline with Friedel-Crafts reagent. Now, most of the time, students don't see the aniline group, and the usual instinct is to do the Friedel-Crafts reaction. So they just do this. But this is wrong, as electron cloud on the nitrogen is very dense, as nitrogen is an electron rich group. So AlCl3, instead of attacking on CH3Cl, will directly attack on the aniline to form the salt. And it would become the ionic bond. So CH3Cl wouldn't be able to react with AlCl3, so no reaction would occur. This is a very important question. It could be asked as a trick, and there are very high chances of doing this silly mistake. Next question. Now it is a chlorination reaction in presence of light So light would break the chlorine molecule and form the chlorine radicals. Now in this case, free radical reaction occurs. Here we don't see the stability of the radical. Here a order comes of degree of hydrogen, that when chlorine reacts, the 1 degree hydrogen have 1 value, 2 degree hydrogen have 3.8 value, and 3 degree hydrogen have 5 value. Now we have to add these values according to the number of hydrogen and see if the 1 degree hydrogen number is greater than 3 degree hydrogen, then the chlorine would be attached on the 1 degree hydrogen. If 3 degree hydrogen is greater than 1 degree hydrogen, then chlorine would attach on 3 degree hydrogen. Here there are 9 1 degree hydrogens and 1 3 degree hydrogen. So 9 ones are 9 and 5. So this is great. So the chlorine would attach on the 1 degree hydrogen, which would lead to the formation of this. Next question. Here the tertiary butoxide ion is present in presence of tertiary butyl alcohol. Now this is a E2 reaction, E2 elimination, but here the reagent is very bulky, so the steric hindrance would become a factor. So instead of attacking on this group, it would attack on this point due to less steric hindrance. So the final product in this reaction would become this. As tert butoxide is a very bulky group, so it would face a huge repulsion if it attacks on here. Next question. Here we have a 2-fluorobutane in the presence of strong base. So when bad leaving group and a strong base is present, so instead of E2 reaction, here occurs something called E1CB. In this, the intermediate is carbanion. What would occur with, let's see it. The base would attract the hydrogen ion from here, forming CH2 minus, and this fluorine would take the electron from here, leading to a occur of positive charge here, forming the double bond and leading the product a Hoffman product. Next question. Butene in presence of Br2CCl4. So this is a syn addition. Reaction is anti-addition reaction. In the double bond, the Br2 would get partially polarized, leading the attack. So the bromine plus would attack on one side and bromine minus on other from other side, leading the dihalogenation of the compound, forming 2,3-dibromobutane. Next question. Chloroethane in presence of AgCN and KCN. Now AgCN is covalent. So here the nitrogen have a lone pair So it would attack on the Cl, leading to the formation of CH3, CH2 and this. Isocyanate would be produced if AgCN is present, but in KCN it is an ionic bond, so the negative charge is on carbon. So carbon have a lone pair, so it would attack on Cl. So this would lead to the formation of cyanide. So if the cyanide is ionic, when the ambidental nucleophile, because it have two places of attack, so it is called ambidental. So in case of ambidental nucleophile, if it is ionic, then next question, propene in presence of NBS CCl4. Now NBS causes the allylic substitution. You should remember this, it is an important point. Just remember that it caused allylic substitution, your answer would come. So the product would CH2 Br single bond CH double. The full form of NBS is N-bromo succinamide. Next question. It is a hexane in presence of AlCl3, HCl and heat. Now this is a isomerization reaction. Here the hexane would turn in its isomers. So the possible isomers of N-hexane would be this, or it could be this, or this. So these three isomers are of N-hexane, so the reagent would act on N-hexane and these three products would be formed. Any doubts you could ask in the comment section. Thank you.